Hey guys, in this video I'm going to be showing you an example of a binomial distribution question where we need to use the conditional probability formula. A similar question to this was asked in the multiple choice section of the 2021 Maths Methods exam, and more than half the students, that's 52% of the students, chose the wrong answer. And so hopefully after watching this video you should feel confident answering these types of questions. For today's video we've got a fair coin is tossed 5 times. Calculate the probability of obtaining greater than 3 tails given that at least 1 tail was obtained. When tossing a coin, the outcome of each toss is independent of each other. And so if we define x as a binomial distribution NP, where x is going to be the number of tails that we get, n is going to be the number of times we toss the coin, and we're told that this is 5, and so n is going to be 5. P, the probability of success, is going to be the probability that we're going to get a tail. And so being a fair coin, this is going to be a half. And so the probability of obtaining greater than 3 tails, given that at least 1 tail was obtained, can be written as the probability that x is larger than 3, given that x is larger than or equal to 1. And using the conditional probability formula, this is going to be the probability that x is larger than 3 intersection that x is larger than or equal to 1, divided by the probability that x is larger than or equal to 1. If x has to be larger than 3, and we want the intersection where x is larger than or equal to 1, then this intersection is going to be for x values larger than 3. And so this is going to equal the probability that x is larger than 3 divided by the probability that x is larger than or equal to 1. From here, we can use the binomial CDF command in the calculator to work this out. For the numerator, the number of trials, we've got 5. The probability of success is going to be a half. Now the lower bound, this is where you need to be careful. We want x to be larger than 3, which means that we're not including 3. And so the lower bound is going to be 4. And the upper bound is going to be 5. For the denominator, the number of trials is still the same, the probability of success is still the same. The lower bound, this time we want to include 1 because we want x to be larger than or equal to 1. And the upper bound is going to be 5. And so this is equal to 0.1935. However, if we wanted an exact value, then we go to menu 2 and then 2 for approximate to fraction, and then enter, and we're going to get the exact value. And so this is equal to 6 on 31. And that's it for this question. I hope you found this video helpful, and if you did, subscribe to this channel to see more videos like this, or comment below and let me know your thoughts. Now that you know how to answer this question, try and see if you can answer exam style questions similar to this one. All you need to do is log into the Maths Methods Club, and from the main topics select probability, and then from the subtopics select binomial distribution, go to question type, select multiple choice, and then click on filter. This is then going to instantly group all the past Maths Methods exam questions in the multiple choice section related to just binomial distribution questions. You should now be able to answer the 2021 multiple choice question 15, which was a similar question to the one we just did in this video. And after that, try out all these other binomial distribution questions asked in the previous exams. This way, you can test your understanding on this topic and also be exposed to a variety of ways that you can be asked binomial distribution questions. Go through these videos, and if you get stuck, just watch the video solutions to help you out. This way, you're going to be much better prepared for your SACs and exams. Good luck, and I'll see you guys in the next video.